Hello everyone, I am Pradeep Kumar, Mathematics faculty at Toppers Academy. Today we'll discuss the toughest question of IIT-JEE, okay, in the history, that is in year 2016, okay. So question here, let fx is equal to limit n tends to infinity n power n and this thing to whole power x by n for all x greater than 0. And you have to find the correct options, okay, and this is multi-correct question. So let's start with this. So sir, fx is equal to what? Fx is equal to limit n tends to infinity. And if you simplify this expression, that is what? That is n power n. And this can be written as x plus n by 1. Yes. Second term can be written as 2x plus n by 2. And so on. And the last term is what? That is nx plus n whole divided by n. Okay, and this expression is divided by, that is n factorial, and this can be written as x square plus n square. Next is what? Next is 4x square. Yes, when you take the LCM, you will get what? 4, and this is 4x square, that can be written as 2x whole square. So 2x whole square plus n square, okay, into next term is x square plus, or you can say that is what? When you take LCM, this is nx whole square plus n square divided by n square, okay, and whole to the power x by n. Okay, now sir, this can be written as limit n tends to infinity n power n, and you can say in the denominator you have 1 2 3 4 till n, okay, and that is what? Product of 1 to n, that is n factorial. So that is n factorial into, you can say that is n plus x, next is n plus 2x, and so on, and the last one is n plus nx, okay, and whole thing is divided by, that is n factorial as it is, okay. Again, if you take x square plus n square by something, that is what? That is 1 square, and 4 is 2 square, next time having 3 square. So you can say in the denominator we have 1 square into 2 square into till n square, okay, and into, that is n square plus x square into n square plus 2x whole square, and so on, that is n square plus nx whole square, okay, and whole to the power x by n. Clear? Now sir, when you simplify it, you will get what? So you can write this thing as a product, okay, this thing as a product. If you observe, that is n plus 1 into x, n plus 2 into x, and so on, n plus n into x, okay. So we can say fx is equal to limit n tends to infinity, that is n power n divided by n factorial, product of what? This is what? Product of n plus rx. Yes, n plus rx. You can say that is product of n plus rx, where r is from where to where? R is from 1 to n. Okay, you can write this thing as r is from 1 to n, product n plus rx, okay, and in the denominator you have, that thing is divided by n factorial, okay, and divided by, this thing is what? 1 square, 2 square, 3 square till n square. So that is what? That is 1 into 2 into 3 into till n whole square. So this is n factorial square, that is n factorial square, okay. Next term, this is n square plus x square, n square plus 2x whole square, and so on, okay. So we can write this thing as product r is equal to 1 to n, n square plus rx whole square, whole to the power x by n. Got it? That is what? That is n square plus 1 square into x square, okay, or you can say n square plus 2x whole square, n square into nx whole square. So you can say that is product from r is equal to 1 to n, n square plus rx whole square. Got it? Now sir, next thing is, now you can cancel your common factors here, n factorial with n factorial. You can cancel this n factorial with this n factorial. So we have limit n tends to infinity, okay, limit n tends to infinity, that is n power n. You can take what? N common, okay. How many times? You can take, if you take n common, so you can say that is summation r is equal, sorry, pi product r is equal to 1 to n into 1 plus rx by n. Okay, and divided by product r is equal to 1 to n. If you take n square common, that is n square into 1 plus rx by n whole square and whole to the power x by n. Got it? Now, sir, this is in the product. So how many times you have n square, n square, n square? N times, yes. So, sir, that can be written as limit n tends to infinity, n power n. And again, how many times we have n? N times, n into n into n into n. That is n power n, okay, n power n. And product r is equal to 1 to n. This is 1 plus rx by n and whole divided by, that is n square, how many times? N times. So n square, n times. Yes. So that is n square to the power n. Product r is equal to 1 to n. This is 1 plus rx by n whole square to the power x by n. Got it? Next one. So this is n power 2n. This is n power 2n. You can cancel this. Okay. And we left with what? That is a limit n tends to infinity. Okay. And this is product r is equal to 1 to n 1 plus rx by n divided by product r is equal to 1 to n 1 plus rx by n whole square. Okay. And whole to the power x divided by n. Okay. So this is what, this is your f dash x. Sorry, fx. This is what, this is your fx. Okay. Now, sir, let's take this term. This term. Now, if you take this term as some a and take this term as some b. Okay. Or let's use the different color. That is b. Okay. Now simplify your a and b. So a is what? Now a is equal to, sir, we can say a is equal to product r is equal to 1 to n. Yes, 1 to n 1 plus rx by n. Got it? 1 plus rx by n. Okay. If you simplify it, you will get what? 1 plus x by n, 1 plus x by n, yes, into 1 plus 2x by n and so on, 1 plus nx by n. So if you take the ln, so you will get what? ln a is equal to, now this, you can apply the property, that is ln a into b, that is what? ln a plus ln b. So you can apply the property ln a is equal to ln of 1 plus x by n plus ln of 1 plus 2x by n plus so on plus ln of 1 plus nx by n. Okay, and this can be written in the form of sigma notation. Yes, ln 1 plus x by n and so on. This can be written as sigma ln of 1 plus rx by n. Yes, ln of 1 plus rx by n, where r is from where to where? 1 to n. Got it? So this is what? This is ln a. Similarly, you can find ln b. Yes, ln b is what? Similarly, you can say ln b is sigma r is equal to 1 to n. Sigma r is equal to 1 to n. And this is ln of 1 plus rx by n whole square. Okay, rx by n square. Okay, so that is what? That is ln b. Now if you subtract it, when you subtract it, you will get what? ln a minus ln b is ln a minus ln b, because you want what? You want a by b. Yes, here you want what? A by b. So in terms of ln, you have to do what? You have to do ln a minus ln b. Now you can apply your formula, that is ln a minus ln b is ln a by b. Okay, so ln a minus ln b is what? ln a is here, okay, sigma this, and this is ln b. So you can say ln a is sigma r is equal to 1 to n 1 plus rx by n minus, sorry, that is ln. Okay, that is sigma r is equal to 1 to n ln 1 plus rx by n. Okay, and minus sigma r is equal to 1 to n, that is ln of 1 plus rx by n whole square. Got it? ln 1 plus Rx by n whole square. Okay. So this is ln A by B, and this thing is equal to, you can apply what? Sigma property of your sigma. Yes, R is equal to 1 to n, that is sigma A minus sigma B. Yes, you can say sigma A minus B. Okay, so that is R is equal to 1 to n ln 1 plus Rx by n minus ln 1 plus Rx by n whole square. Got it? And this is ln A by B. Okay. Now you can find A by B. A by B is what? A by B is, use the definition of your ln, that is A by B is e power this, e power sigma R is equal to 1 to n ln of 1 plus Rx by n minus ln of 1 plus Rx by n whole square. Okay. That is what? That is your A by B. Okay. Now put the value of A by B in your star. Star is where? This is your star. Let's say that is your star equation. Okay. So fx is equal to what? Fx is equal to limit n tends to infinity A by B. So we can say, put this thing in star, put A by B in equation star. Then we'll get what? We get, sir, fx is equal to limit n tends to infinity A by B. Yes, A by B is what? E power sigma R is equal to 1 to n ln of 1 plus Rx by n minus ln of 1 plus Rx by n whole square, and whole to the power x by n. Yes. Now sir, e power something and that to the power something. So we can say, apply the formula of your x power m to the power n. That is what? That is x power m into n. Yes. X to the power m, whole to the power n. That is x power m into n. You can multiply your powers. Okay. M into n. That is x power m and whole to the power n. So you can say this is limit n tends to infinity. Limit n tends to infinity. And this is e power sigma R is equal to 1 to n ln of 1 plus Rx by n minus ln of 1 plus Rx by n whole square, okay, into x by n. That is into x by n. Got it? Now sir, now we can say fx is equal to what? Fx is equal to limit n tends to infinity. Okay, or you can apply what? You can apply the property of your limit, that is limit of e power something, e power fx, that is e power limit of fx. Okay, so this will become e power limit n tends to infinity, and this is sigma R is equal to 1 to n, ln 1 plus Rx by n minus ln 1 plus Rx by n square, okay, into x by n. Okay. Now there is no limit on x, so you can take outside the limit. So this will become e power, okay, e power x limit n tends to infinity. Okay, and that is, now this sigma is what? Sigma is on here. Okay, yeah, sigma is here. So you can say 1 by n into sigma R is equal to 1 to n ln of 1 plus Rx by n divided by, now you can apply the formula what? Ln A minus ln B. Okay, ln A minus ln B, that is ln A by B. So ln 1 plus Rx by n upon 1 plus Rx by n whole square. Got it? Close this bracket. Okay. Now sir, now observe this part. Let's say that is your alpha. That is what? That is some alpha. Okay. So this is your alpha. So alpha is limit n tends to infinity. Alpha is limit n tends to infinity 1 by n sigma R is equal to 1 to n ln of 1 plus Rx by n divided by 1 plus Rx by n whole square. Yes or no? ln 1 plus rx by n upon 1 plus rx by n whole square. Okay. Now sir, you can use what? Now you can use your definite integration here. That says put r by n as what? R by n as some y or t. Okay. Put r by n as, put what? Put r by n as t. Okay. Then your 1 by n is what? 1 by n is some dt. Okay. 1 by n is some dt. And your sigma becomes what? Your sigma becomes your integration. Okay. Okay. This is from the definite integration. R by n tends to, you can put r by n as t, 1 by n as dt, and sigma changes in your integration. So alpha will be what? Alpha will be, sir, limit n tends to infinity. Okay. And this 1 by n, that is sigma r is equal to 1 to n, that is integration. Okay, integration. Now sir, r is equal to 1. R is equal to 1. So 1 by n, that is what? Where n tends to infinity. So this tends to 0. Now sir, if you put n by n, so that will become what? That will become 1. Okay. Now sir, this is ln 1 plus r by n is t. So this is 1 plus tx upon 1 plus t square x square. Okay. And into dt. Got it? Sigma converted into your integration. Ln 1 plus r by n as t. So tx upon 1 plus t square x square. And this 1 by n, this limit tends to dt. Okay. And sir, how can you find the limits? Sir, because the lower limit is what? R starts from 1. And you are putting 1 by, if r is 1, then you can say 1 by n is what? 1 by n is when n tends to infinity is 0. Okay. Similarly, when r tends to n, so n by n is what? N by n is 1. When n tends to infinity, 1 is 1. So that is 1. Okay. So this is alpha is equal to 0 to 1 ln 1 plus tx upon 1 plus t square x square dt. Got it? Now sir, let's say this equation is your double star. This equation is your double star. Okay, that is double star. So you can say fx is equal to e power x alpha. Okay. Put alpha in double star. So we'll get what? We get, sir, fx is equal to e power, fx is equal to e power x alpha, x into alpha, x into alpha. So x into alpha, that is 0 to 1, and ln 1 plus tx upon 1 plus tx whole square, you can say, yes, into dt. Okay, now you can say this is what? E power integration 0 to 1. You can take this x inside your integration because we are integrating with respect to t. Okay, so that is what? That is x into ln of 1 plus t x upon 1 plus t x whole square dt. Okay. Now sir, now put tx is equal to some m. If tx is equal to some m, so you can say x dt is equal to dm. Yes, x dt is equal to what? Dm. So fx is equal to e power, fx is equal to e power integration when t is 0. When t is 0, so m is also 0. And when t is 1, lower limit is what? 0. So you can say that is 0. Upper limit is 1. So you can say if this is 1, so you can say that is x. Okay. And x dt is what? That is dm. So ln 1 plus tx, that is m, 1 plus m upon 1 plus m square into dm. Okay. That's your fx. That's your fx. Got it? This is your function fx. Okay. Now you can find what? You can find the derivative. So derivative is what? Derivative. So you can say f dash x is, if you find the derivative, so f dash x is equal to, you can say apply the chain rule here, e power something. So you'll get what? E power the same thing. Yes. E power integration 0 to x ln of 1 plus m upon 1 plus m square dm. Okay, e power integration 0 to x ln 1 plus m upon 1 plus m square into dm. Okay, into differentiation of this, and if you apply the if you find the differentiation of this, now you have to apply what? Leibniz here. Okay, Leibniz say that is ln of 1 plus x upon 1 plus x square into differentiation of x, that is 1, minus, when you put 0, you will get what? Ln of 1 plus 0 upon 1 plus 0 into differentiation of 0 is 0. Okay, so that thing is what? That tends to 0. That tends to 0. Clear? That tends to 0. So we can say f dash x is, so the same thing. If you observe, that is what? That is fx. Yes, that is fx. So you can say f dash x is equal to fx into ln of 1 plus x upon 1 plus x square. Got it? And this thing is 0. So you can say f dash x is equal to this one. Okay, or you can say f dash x upon fx is equal to ln of 1 plus x upon 1 plus x square. Got it? Okay. So these are two, you can say, forms of your f dash x. F dash x is equal to fx ln 1 plus x upon 1 plus x square. Second is f dash x upon fx is equal to ln 1 plus x upon 1 plus x square. Okay, now let's move to the options. First of all, let's check your third option, D option. Okay, D option. D option. So D is f dash 3 upon f3 and f dash 2 upon f2. You have to find the relation between this. Okay, f dash 3. Now, sir, you can find the relation using this one. Okay, for D option, we can do what? For D option, we can put x is equal to 3. Put x is equal to 3 in second. Let's say that is your second equation, and let's say that is your first one. Okay, if you put x is equal to 3 in second, so you'll get f dash 3 upon f3 is equal to what? Ln of 3 plus 1, 4 upon 9 plus 1, that's 10, which is ln 2 by 5. Okay, and similarly, if you put 2, put x is equal to 2, put x is equal to 2, so you'll get f dash 2 upon f2. F dash 2 upon f2 is equal to what? That is ln 3 upon 5. Yes, 1 plus 2 square, that is 5. So ln 3 by 5. And you know, ln is what? Ln is an increasing function. Okay, that's an increasing function. And if this is increasing, so means bigger the input gives you the bigger value. Which one is greater, 2 by 5 or 3 by 5? So 3 by 5. Yes, so it means ln 3 by 5 is greater than what? Greater than ln 2 by 5. Okay, and ln 2 by 5 is what? Ln 2 by 5 is f dash 3 upon f3. F dash 3 upon f3. So it means f dash 2 upon f2 is greater than f dash 3 upon f3. But my option is f dash 3 upon f3 greater than or equal to this. So this is a wrong answer. Means wrong option. Okay. Now check the option C. That is f dash 2 less than or equal to 0. Okay, f dash 2. Now let's observe f dash 2. F dash 2. So sir, put the value. Put x is equal to 2. Put x is equal to 2 for option. Or let's write on the next page. Or here. For option C. For C option. For C option. Put x is equal to 2 in equation 1. Okay, in equation 1. When you put x is equal to 2, you will get what? F dash 2 is equal to f2 into ln of, that is 3 by 5. Yes, ln 3 by 5. Now sir, f2 is what? Now back to the question. f2 is this one. When you put x is positive, x is equal to 2. So this is positive, you'll get something positive. Yes, basically that must be non-negative. Okay, maybe 0, I don't know. But yes, that is not negative value. Okay, that is not negative. So that is non-negative, you can say. Or actually this is positive. Yes, no problem with that, non-negative. And ln 3 by 5 is what? Now we know one property of your logarithm, that log a to the base b, log a to the base b is positive. Okay, log a to the base b is positive, and base and number a and b are on same side of 1. And if they are on opposite side of 1, then you will get the negative value. Okay, ln 3 by 5. 3 by 5 is smaller than 1. And base of ln is e, which is 2.718. So both are on the opposite side of 1. So this is negative. That is what? That is negative. Negative. Okay, so whole thing is what? If you observe here f dash 2, so whole thing is what? Whole thing is, sir, you can say f dash 2 is non-negative and negative. That will be non-positive. Okay, f dash 2 is less than equal to 0. Got it? Let's say this is 3, this is negative, so negative value. So f dash 2 is less than equal to 0. Got it? So it means f dash 2 is less than equal to 0. So C is the correct option. Now, sir, for first and second, let's take your expression, this one, f dash x is equal to this. Okay, now f dash x is equal to fx ln 1 plus x upon 1 plus x square. Yes, f dash x is equal to fx ln 1 plus x upon 1 plus x square. Now, sir, if you take x from 0 to 1, if you take x from 0 to 1, okay, if x belongs to 0 to 1, then f dash x is what? Positive, negative, what it is. Okay, if x is from 0 to 1, so what about fx? What about fx? Fx, if x is positive, so this thing is positive. Yes, this thing is positive or non-negative. Basically, you can say that is non-negative. Yes, that is non-negative. That is non-negative. And sir, if x belongs to 0 to 1, so we know x is what? X is, if x is, or let's start with here, if x is from 0 to 1, okay, if x is from 0 to 1, then we can say x square is what? X square is less than x. Yes. And if you add 1 on both sides, inequality remains same, 1 plus x square less than 1 plus x. Okay, both are positive also because x is positive. Yes, 0 to 1. So 1 plus x square is what? Less than 1 plus x whenever x belongs to 0 to 1. So it means, if you observe here, 1 plus x, that is greater than 1 plus x square. 1 plus x is greater than 1 plus x square. So it means that thing is what? That thing is greater than 1. Okay, this is greater than 1. If this is greater than 1 and ln of something which is greater than 1, that will be positive. That will be positive. So that is positive. Okay. So this is positive. This is non-negative. So your f dash x is what? That is non-negative. Okay. And if this is non-negative, you can say that is f dash x is what? Greater than equal to 0. Yes. When x belongs to 0 to 1. So you can say fx is what? Fx is increasing function. Fx is increasing function. Okay, fx is increasing function. If fx is increasing, now let's check your option number A, that f half and f1. F half or f1. F for A, for option A. F half and f1. And we know 0 to 1, my function is increasing function. So bigger number having bigger value, 1 is greater than half. So f1 is what? Greater than f half. Okay. And for option B, that is f of 1 by 3 and f of 2 by 3. Greater than or less than or equal to, you can say f1 by 3 is or f2 by 3. What is the relation between them? 1 by 3, 2 by 3. Which one is greater? 2 by 3. 2 by 3 is greater and f is increasing. So it means what? F2 by 3 is greater than equal to this. F1 by 3. Okay. So now you can say f1 by 3 less than equal to f2 by 3. Yes. Okay. So you can say option B is the correct one. And f half is greater than equal to f1. F half is greater than equal to f1. No. F half is greater than equal to f1. No. So it means A is what? A is your wrong answer. Okay. Wrong option basically. So you can say what is the final one? So final answer is what? Final answer contains your B option and C option. Okay. So finally you have final answer that is B and C. Okay. So this is your question. फ्रॉम द प्रीवियस ईयर्स, ओके। एंड आई थिंक ये सबसे टफ क्वेश्चन होगा आज तक का कैलकुलस के ऊपर, क्योंकि इसी क्वेश्चन में आपके पास इंटीग्रेशन भी पूछ लिया है, डेफिनेट इंटीग्रेशन भी पूछ लिया है, और आपको एक्सपोनेंशियल फंक्शंस के बारे में पता कर लिया, एलएन के बारे में भी पता कर लिया, और एप्लीकेशन ऑफ डेरिवेटिव का भी पता कर लिया। ठीक है, तो ठीक है, आज के लिए इतना ही। नेक्स्ट वीडियो में कुछ और इंटरेस्टिंग चीजें देखेंगे। तब तक के लिए थैंक यू।